So I'm Allie, and I'm from ShopRunner. We are an e-commerce company, as has been mentioned, and we work with a variety of retailers who sell all sorts of things. But in particular, we're interested in the fashion space, and over the last 8 or 9 months, we've been putting together our own computer vision program in our data science team, basically from the ground up. So this talk I'm giving today is going to be a summary of some of the things that we learned along the way. So a quick agenda. I'm first going to introduce you to ShopRunner and our products, and then some of the things that we use computer vision for. Then I'm going to run through a series of key questions to ask yourself if you're thinking of dipping your toes into computer vision in your own company. And I've divided those questions into 3 different subject areas, those involving your data, your infrastructure, and people. So at ShopRunner, we call ourselves Amazon Prime for everyone else. So we have, as has been mentioned, 6 million members and a growing network of over 140 retailers. And our members get free 2-day shipping, returns, and a variety of deals across our retailer network. And our retailers, in return, get new customers who tend to be very engaged and have very high average order values. And so I put some of our retailers up here. You'll hopefully recognize some of them. So one of the ways we do this is by adding a layer of JavaScript to the websites of our retailer partners. And what that layer does, one of the things it does is adds this call out to ShopRunner that if you're a member and you're logged in, you get that automatic free 2-day shipping and returns. And if you're not logged in, it'll tell you how you can sign up. So with Kohan in particular, you can place a larger order and get a free membership, or you can also get a free membership through several of our partnerships with other rewards programs. And as you can see here, that includes American Express and PayPal. But it's not just about the free 2-day shipping. There's a whole catalog of products that we bring to our retailer partners, and that includes express checkout, and more recently, a new product where if a customer abandons their cart, we send them a follow-up email with suggestions for other things that they might want to buy. We also have a members website for ShopRunner members to get personalized content relating to our retailer network. So if you sign in, you can select your favorite stores and then get recommendations from those particular stores. In particular, you can see what's trending, and then you can search for products across our network. And also, very excitingly, we have a new mobile app that is launching actually next week. It is called District. It's going to be hitting the Apple App Store in just a matter of days. This is a soft launch we're doing right before the holidays. There'll be more marketing activity in the coming months. But here are a few screenshots of what it looks like. The main landing page of the app is our trending feed. So it shows you what's trending right now across your personally designed shopping district. So you can select amongst our retailers which ones you want to be in your district, and then see what's hot or new or popular from those retailers. In the center screen, I'm showing a screenshot of our universal cart. So you can assemble outfits or just buy multiple things from across our retailer network all in one cart at the same time. And then on the right-hand side, showing one of our retailer pages. So it's very retailer first, giving you very personalized content, both to help you discover things you might want to buy, but then also let you search for things when you have that intent. So the one most straightforward things that people in the fashion space want to use computer vision for is for item classification and attribute tagging. This is especially important if you have data from a bunch of different retailers like we do. So all of our 140 retailers send us feeds of product data every day. And what Neiman Marcus puts in their data feed as attributes or in their taxonomy is going to be different than what, say, Bloomingdale's will put in their product feed as their taxonomy in their product tagging. And at ShopRunner, we have our own master taxonomy that we want to put everything into so that, for example, in the district app, if someone's searching for something or they're browsing for a particular type of product, that they can find it using this one master taxonomy. So one thing you can do with computer vision is just for every image, give it one classification, one label. So that's what I'm showing on the top part. It's the placement in our taxonomy. So let's say our taxonomy is a tree, where at the top level we have, say, unisex, kids, men, women. And then for every one of those top level classifications, it's split out into more granular classifications. So for example, under women, we might have clothing, accessories, shoes, bags, etc. And so in our taxonomy, we have a bunch of leaf nodes that are different classifications that our products might fall into. So for example, for this dress here, placing it in our taxonomy, it's going to go in the leaf node that's for women's clothing, dresses, and evening dresses. And so this is a classification that we want to do for all of our images when they come in. Another thing that we might want to do is to assign attribute tags to all of our products. And this can also further help in personalizing any feeds or helping in relevance or searching or browsing behavior is to know, for example, color, sizes, styles, occasions where you might wear something. So those are also interesting pieces of information to have. So you can also design a computer vision model where instead of just one master classification, instead you have multiple labels that you could assign to the image. So for this product here, we might have tags like, say, for the color, olive green, it's a midi dress, and it's sleeveless. I should say through all this process, I've learned a lot about different clothing types and what even like a midi dress even is. So I'm not a very fashionable person, so it's been a learning experience for me. Okay. All right, thanks. Another thing that we do with computer vision is visually similar search. So you can take the data from one image and then compare it to the data and the pixels of another image and see if they are in the similar style to each other. And you can do that with computer vision models. And so one example of using that in a product for an e-commerce site like ShopRunner is by helping people find other things that look like one thing they're looking at. So let's say someone looks at this ball gown at the top, and for whatever reason, they want to see other products that look like that ball gown. Maybe that ball gown is too expensive, or they just really like that style and want to stock up on ball gowns. So what we can do is compare that image to all the other images in our catalog, have a similarity score, and then rank products based on that similarity score and return that back to the user. So the first type of questions that you should ask yourself are regarding the data that you have, and not just what your image data is like, but what you want to get out of that image data. So if you want to try to use any kind of pre-developed API for computer vision, or if you want to use a pre-trained model, those models are only going to work if your data is very similar to what was used to build that model that you're using. So how similar is your data, not just the images, but also the labels you want to get back out? How similar is that to data sets that were used to build any kind of pre-trained APIs or models that you want to use? Another question is, do your images contain multiple objects that need to be detected? So if, let's say, every image you have has only one classification you want to assign to it for the entire image, that's going to make it a lot easier to use pre-trained networks or out-of-the-box APIs. And if instead you need to detect images in your, detect objects in your images or segment them out. Just know that that's going to be a more complicated task that's probably going to require more customization. In particular, the most popular data sets that are used to train a lot of pre-trained models that you can find on the internet, most of those are made with either ImageNet or the CIFAR data sets. And those are open out in the public data sets. You can look up their information. You can get the actual data and look at it and compare it to the data that you have and see how similar it is. So on the right, I'm showing some information from the imagenet.org website. So you can just go there, get image stats, get all the information you want. ImageNet has 1,000 classifications, and you can find those. There are things like amphibian, animal, appliance, bird. And then CIFAR 10 has 10 different classifications, and CIFAR 100 has 100 different classifications. So on the left, I'm showing an example from the CIFAR website on what is in CIFAR 10. So CIFAR 10 has airplane, automobile, bird, cat, deer, dog, etc. A lot of animal pictures here. So if your data is really similar to these, then you could probably use a pre-trained model extremely easily. And just know that any out-of-the-box API that you might use, and I'm going to list some of them very soon, any out-of-the-box API you use is going to be what we call fine-tuned to whatever the use case is that you're looking at. So that's a very key phrase that you can look up, fine-tuning. So even if, say, I'm using a ResNet model that was built from ImageNet that has this amphibian, animal, appliance type of labels, there is a very standard methodology in computer vision called transfer learning, where you can take that model and you can add new layers onto the end of it, or you can just tweak the parameters of the model itself to specialize it to somewhat different data sets. And so that's something that we do at ShopRunner. So let's say your use case is sufficiently different than what you can find from an out-of-the-box computer vision API, and you want to build your own model, or you want to fine-tune an existing pre-trained model. To do that, you need labeled data, and the amount of labeled data you need depends on how from scratch you're starting with your model. So if you want to build a new, completely different custom architecture from the ground up, you're going to need a lot of training data, and you're going to need a lot of labels for every class you're looking at. But let's say you want to do transfer learning or fine-tuning, like I just mentioned, which is really the industry standard. You really only need maybe 100 to 1,000 labeled examples per class. And there are a variety of different ways to get labeled data. There are very, very many publicly available labeled data sets open sourced on the internet. And if you're lucky, maybe one of those labeled data sets is actually exactly what you want, both in terms of images and labels. Or you can take, if what you're interested in is a subset of one of those labeled data sets, well, then you can just sample it down to the classes that you're interested in. So one example here is Google's Open Images. The slower but more accurate method to get new labeled data is to just crowdsource from within your own company. I've heard lots of stories of people doing this. Just buy people a bunch of pizza and just set them up with some annotation tool and make them work on this for a few hours here and there. There are a lot of annotation tools that make this a lot faster than just logging things in a spreadsheet. One of those is called Label Me. But if you just look up annotation tool, you'll find a lot of options. And then a much faster but somewhat less accurate method is crowdsourcing from the outside. So I say it's faster because you have way more people working on it. But I can say that it's probably going to be less accurate because the people labeling are not going to be domain experts like you have in your company. I listed out some of these options, and they all have varieties of pricing tiers depending on your needs and your funds and how much data you need. We at ShopRunner use Figure 8 which is formerly called Crowdflower, to do our hand annotation. But there's also Amazon Mechanical Turk, and ShopRunner actually recently acquired another e-commerce startup called Spring, and they use TaskUs for their data annotation. Also, what kind of outputs do you need? So do you just need labels, just need text terms like a classification or image tagging, or do you actually need what we call embedding vectors? So that's where you basically chop off the last layer or so of your neural network, and you just look at basically a vector representation of the image. So it's kind of a way of doing dimensionality reduction. So you take this big image of data and you condense it down into a vector, and those vectors you can compare to each other. So this is good for nearest neighbor search for visual similarity. At ShopRunner, we use Spotify's Annoy, but there's also other packages to do nearest neighbor searches for vectors, like Facebook's Face package. Those are both open source. But also having what we call these embedding vectors can be useful for concatenating on other pieces of information. So one example of what you might want to do in the e-commerce fashion space is concatenating textual information onto your image information. So what you can do is have two separate models, one that takes your image and condenses it down to an embedding vector, but then you can take a textual description and condense that down to an embedding vector, and then tack them onto each other, and then pass that into a final step, like maybe another neural network layer, maybe an SVM or random forest, and get a much better classification that way. I'm showing an example where that's super helpful. This is an actual example from our product catalog. We get this image from a retailer that has this full body shot of a model wearing this outfit, but the name of the product is Mix Print Top. So what we find is that the image might be a full body shot of the model, but the product is actually just the top. So when you combine those two pieces of information together, you find that the category is tops. So that sort of thing can be very important if you have pictures of models that are wearing various, wearing a shirt and pants and shoes, like which one is the image referring to? This is a way you can get at that information. So I'm going to walk through a few fully out-of-the-box options. I encourage you to go to the actual website and see if any of these would meet your needs. There are a lot of options out there, but just to run through the few of them, Google Cloud has some options for computer vision APIs. They can do image classification into preset categories. They can do face detection with emotion and headwear. They can do OCR, so detecting and labeling handwritten characters or any kind of characters, I guess, text in images. And then they can also do a search for similar images either on the web or from within your own product catalog. Microsoft Azure has several APIs for computer vision. So they have the standard API for image classification, image tagging, and again, character recognition. And then they also have Face API for face detection, features, and recognition. So face detection is a very important part of most of the out-of-the-box APIs. It's an extremely difficult problem. So if you're looking for face detection, I'd say an out-of-the-box API might be your best bet. They also have Content Monitor for filtering out objectionable content. That's another thing you'll find with a lot of these out-of-the-box APIs is content filtering, which AWS Rekognition also has. This also has basic object tagging for both images and videos, OCR, content filtering, and Rekognition is known for its excellent ability to detect and recognize people. So again, if you wanted to use any of these out-of-the-box options, you have to think really hard about what the data, what the images were used to build these APIs, and what the labels are that they're giving you, and make sure that those line up extremely well with your use case. If you need some level of customization, but you don't have the resources to actually write code, there are also options for that. So I'm just going to walk through a few of those. There's Google AutoML Vision, which is based on what's called a neural architecture search. So it does a search to try to find what's the best architecture for your problem. And you can drag and drop data via user interface. So you don't have to write any code to use it. Clarifai has a variety of models. Some of them are beta. They're constantly adding new models, but they can also provide the embedding vectors for what they call their general model. So that can be useful, again, for doing visual similarity and concatenating on other pieces of information, like from text. And then there's IBM Watson Visual Recognition that has some default models, including face detection, OCR. So let's say you've either looked into all of those options and you didn't find anything that really suits your particular use case very well, or maybe you have used one of those existing solutions, but there comes a point in time where you just need the customization that you can get from building your own models yourself in-house. So there are some issues relating to infrastructure for doing that. So for training and deploying, you're going to need some sort of hardware to do that, and that hardware is going to involve computational abilities and data storage. So computer vision typically is done best on GPUs. So you want you definitely do not want to use CPUs for this. You can, but it's going to be just amazingly slower. So you need some way of having GPUs, and then you also need to be able to store all your data. Image data can take up a lot of space, especially if you need, if you have like, say, 1,000 different categories and you have 1,000 different images for each of those categories, the data size will really add up fast. So another question is regarding how much computation you need is how custom do you need your models to be? So are you just doing a little like fine-tuning of an existing pre-trained model, or are you really starting from scratch and building something completely new? That's going to affect both the storage you need and the computational power you need. So just for fine-tuning a pre-trained model, you can get away with having less labeled data, and you can get away with doing fewer training rounds, doing fewer experiments and parameter tunings. But if you're starting from scratch and building a completely new architecture, you're going to need way more image data, and you're going to need to train for way longer, and you're probably going to need to do more modeling experiments. So you're just generally going to need more computational power. On the other side, once you have a model and you want to deploy it, it's important to ask yourself what you're deploying that model for. If you're only deploying it for an internal tool, the demand and the latency needs are going to be very different than if you're deploying it for a production system. So if your API is only going to be used in-house by a handful of people, you can get by with far less hardware than if it's going to be hit from the outside with many, many more requests and the needs for lower latency. That's something you need to take into consideration. So there's several traditional cloud provider options for getting you that hardware that you need to do this, where you don't have to actually maintain hardware yourself. A couple examples are AWS and SageMaker, which I've been using a lot lately. There's the Google Cloud Platform and Google Cloud ML, Microsoft Azure. And I don't know if who's familiar with Databricks, but we use it a lot for Spark code, but it also can be useful for large machine learning jobs. So then there's a question of, do you want to use one of these cloud providers, or is it worth it to have on-premise hardware? So that's hardware, like you actually physically have GPUs that you actually physically maintain. The question there really depends on the questions in the previous slide. So how many GPUs do you need? How much storage will you need? As those needs grow, there's going to be an inflection point where maintaining things on-prem is going to become way cheaper and actually in a lot of ways easier than using the cloud systems. So there are a lot of alternatives to a traditional cloud provider. There are actually deep learning optimized cloud providers. One of them is called Paperspace. You can get pre-built deep learning servers that you can buy, but you'll still have to maintain the hardware yourself. And then you can create custom-built on-premises deep learning servers. So I've included here a handy little chart from a blog post that I linked to from Determined AI. The cloud providers and the on-premises hardware will have very similar performance for the same type of GPU, because at the end of the day, the cloud is just GPUs that someone else maintains. So performance will be the same, but the price can be dramatically different depending on how much hardware you need. Also, the setup and maintenance of on-premises is way harder than for cloud, and you'll probably need some expertise in-house to maintain that. And then, depending on what kind of data you're working with, you might have security issues. So the security of on-premise hardware is always going to be better than the security of anything in the cloud, although cloud providers do have some of them are HIPAA certified, and they'll have various certifications that they've gone through so that you can use them for security, for purposes where security is more important. Okay, so the last area I want to talk about is regarding people. So you should ask yourself, what level of coding experience does your team have? Is your team more junior? Do you have more senior people on there? You have some Python experts, because a lot of the popular deep learning frameworks are in Python. So depending on the HR resources that you have, that will affect what kind of a solution you want to have. Maybe if you don't have any coding expertise in-house, you'll have to use one of the APIs I mentioned before, or some of the options for customization without code. But if you do have some coding experience in-house, you still need to ask yourself, what kind of coding framework do you want to use? And there are a variety of deep learning frameworks. There are lower level ones where you have far more fine control over exactly how you build your models. And then there are higher level frameworks where they're way easier to get started with and to build models fast, but you don't have that fine level of control. So I'm going to run through a few of the options that you have in Python. This is not an exhaustive list, but these are the most popular. So TensorFlow is something you've probably heard of before, and is currently the most popular framework for deep learning in Python. Now it has something called eager mode that fixes some of the difficult usability situations that can occur with TensorFlow. It requires a lot of knowing exactly what you're doing up front. It hasn't historically been the easiest framework to do experimentation with. So eager mode makes it a lot easier to experiment with it. There's also PyTorch, which is definitely gaining ground on TensorFlow in terms of ease of use. PyTorch works more like NumPy, so people who are Python coders are going to be more comfortable getting used to the way it feels to write PyTorch code. And then Keras is my personal favorite. It's a higher level library that's built on TensorFlow. It's also built on Theano and CNTK, and it's extremely easy to use pre-trained models. So that's the thing I like about it the best. It's extremely easy for me to just build a model on top of a pre-trained model and fine-tune it without having to write a ton of custom code. And then FastAI is a popular higher level library that's built on PyTorch. So V1.0 was just released. They have a very popular related online course, and actually there are several members of my data science team are currently taking that course. It's very good for learning some of the handy tricks of deep learning, and their course runs through some of those. And then I should also mention MXNet and Gluon. These are less known. There's a smaller community using them, but in terms of performance, that's where Gluon and MXNet really shine. So they scale incredibly well. Gluon is the higher level built on MXNet. But the smaller user base can be tricky if you're working with a team that doesn't have, very high Python skills. So do you hire a bunch of computer vision experts to run this program, or do you just train your existing data scientists to do deep learning? So what we've done at ShopRunner is definitely a hybrid approach. So we actually started with an out-of-the-box API to do computer vision just to get started, just to get that into our products, to get the wheels turning. And in the meantime, we put out a search to hire a computer vision lead. So trying to find a data scientist who has an expertise in computer vision, but who also has the production engineering experience that we need on our team. Hiring someone like that, I can now say from experience, is incredibly difficult. I can say it can take at least 6 months or more to find the right person for this job. But in the meantime, there are tons of options for growing deep learning experience within your existing data science team. Especially if you're interested in some of the more standard things like transfer learning and fine-tuning of pre-trained models. If you have some good coding experience on your team, getting started with, say, Fast AI or Keras actually is not as crazy of a task as it might sound. One of the things we did on my team is we did a Kaggle hackathon together. We took 2 days. We did the Kaggle iMaterialist fashion challenge together. We each chose different ways to do it. So I did TensorFlow eager mode. Someone just did basic TensorFlow and used TensorFlow Hub. Someone used PyTorch. And then we just shared our learnings at the end. That was like a fun way to just start to get started with all this. There are also now a ton of popular deep learning courses that you can find online. So one of them is the Fast AI has a couple courses in deep learning. Like I said, some of my teammates are working through that now. Coursera has a deep learning specialization that you can do. They have a ton of different courses on deep learning. Udacity has a deep learning course, and NVIDIA also has some deep learning certifications. Okay, so that's pretty much all I had. So just to recap some of the things that I've said, there are fully out-of-the-box solutions out there, and those are going to be the easiest path forward, especially if your images and labels are very similar to what they use to build those APIs. That can be a good way to just get something built, get something to your software engineer friends so they can start thinking of products around the computer vision work while you figure out how to build more customized solutions. You can build customized solutions without code, and that can work well if you have somewhat different images and labels, but perhaps you lack enough data to actually build new models yourselves. There are higher level and lower level coding frameworks for building computer vision models. Those are the best for creating very flexible custom models where you can use the embedding vectors to do visual similarity and things like that. And those really are the best option if you want to get the highest accuracy and you want to have the most control over what's happening. In terms of infrastructure, cloud providers can be really great for if you have just a modest need for computing power for this. But if you're going to be needing very large amounts of computing power, there comes a point where the cost-benefit trade-off isn't necessarily worth it anymore, and you might want to go with on-prem hardware. And then computer vision experts are hard to hire, but in the meantime, there are tons of deep learning courses out there so that you can help grow that talent in-house. And thank you very much.
If anyone has any questions.
How much images, labeled images will be allowed?
Okay, so the question was how many labeled images will be enough if you want to build a new computer vision model? Is that what you asked? So you're asking like the examples differentiating between two different types of dresses. So there's no hard and fast rule out there, but you can conceivably build a decent model with only 100 examples from each class. And that can be done by taking a pre-trained model and then adding a couple, doing what we call transfer learning. You take a pre-trained model that was trained on some data set like ImageNet, and then you chop off the last couple layers from that neural network, and then you add on 2 new layers. So basically what the neural network is doing is it's figuring out all those features of images that can be instructive for determining what it is. But instead of doing that last specialization in that last couple layers, you're just adding new ones on that those are now going to learn about dresses. So it's going to say, oh, if I see an edge here or this kind of color here, that means this kind of dress or that kind of dress. So if you're doing just transfer learning and just adding a couple new layers onto something pre-trained, you might need as little as 100 examples per class. But if you want to train like a completely new architecture from scratch, you're going to need way more data. If you want to do fine-tuning of a pre-trained model, so you want to go back with what they call small learning rate and tweak how it works, you might need 1,000 images per class. Yeah, so there's a question of how do you build it into your pipeline when you have images that have multiple objects in them and you might only be interested in one of the objects or another. Yeah, so that's a really good question. So there's some complementary techniques in computer vision. There's, what you might call object detection, where you're just putting bounding boxes around objects. And then there's complementary approach called segmentation, where you take the image and you create boundaries around different items. So a type of pipeline I can imagine you having, if you have a bunch of images where you know there's multiple things in them, is you first send it through a segmentation model where you pick out what the different images are, and then depending on what you want to do with that data, then you have something after it. So like if you want to do visual similarity of dresses, but you know all your dress images also have shoes in them, you can do a segmentation to just crop out just the dress part of the image.
You're going to train that model also.
Yeah, so you need a segmentation model as well. So you'd have a segmentation model that crops out where the dress is, and then it just, you take just that dress data and you use, get the embedding vector for that, and then you compare those. So you just have to insert a segmentation, it's not easy, but like you have to have a segmentation layer in front of it. And bounding box, yes, and also to train object detection, if you want to put bounding boxes around different objects in an image, you need annotated data that has bounding boxes. And that's something that you can get with, all these like image labeling services that I mentioned. I think they all include bounding box abilities. Yeah, so the question was, when you're doing the similarity of images, you also get labels out of that. And yeah, so that same vector that you compare to do similarity, that's what goes into the last layer of your neural network that tells you what the image is. So that vector, if you build your own neural network to do classifications, that vector of, that embedding that you compare across images comes for free. So that's one of the great things about building your own custom model. That's a really good question. Thanks.
Which platform do you use for training and what do you use for inference?
Okay, so what platform do you use for training and what do we use for inference? So currently, we don't have our own custom models in production. They're a work in progress. In production, we're using an out-of-the-box API. But for the work that we're doing, we've been working both in Keras and Fast AI. And I've been working a lot with Amazon and SageMaker for training and deployment. So we've deployed image tagging and image similarity APIs that are in, I guess, what you could call like WIP or staging environment. The image similarity API uses Annoy for nearest neighbors, and it's a Flask API. so it's built entirely in Python. And then the image tagging API that we have is deployed through Amazon SageMaker. Oh yeah, so that's a really good question. Like, how do you make the image similarity search fast? Do you keep the embeddings? Yeah, so we have, it's still something that we're working on. That's a really good question. So, yeah, we can't necessarily pre-compute everything and just store it, right? Because someone, if you want the ability to take in a new image and compare it against your index, you've got to do the comparison on the fly. And so that is something that's really hard to get the latencies down.
Doing it on like attributes like title or description or tags.
Yeah, so the question is like, can you do the description just based on like the text, or like actually if you're just tagging and classifying images, that's another way that you can do similarity between products in a product catalog. So you can have, like, for example, I mentioned the labeling method that we do. So that dress is like olive, midi, sleeveless. We can compare that corpus of text labels to all the other text labels we have for all the other images to figure out what's similar in that way. And that's a way to get actually a faster recommendation API than doing the actual visual similarity. But we want to do actual visual similarity to really capture the style. So like with fashion, it might be different than in other types of research, but in fashion, just like the pattern of a shirt or like a dress is really important. And so that's why it was really important to us to have a visual similarity API so we can really compare those patterns and colors.
Last question.
So, I think, this thing, like how you prove its value or show its value.
So how do we prove and show the value of adding this team to our organization? Yeah, that's a good question. So the computer vision product, like the things that we build on the data science team at my company feed into all of our products. And so as we add, new computer vision capabilities to our products, we can A/B test those products and see, like, does that visual similarity search that we added, what's the lift in conversion rate we get from something like that? So we can put actual dollars on these products and how well they work when they're out in the wild. We're only trying to hire like one computer vision expert to actually like lead this program. A lot of it is actually just building up the talent from within. And actually wanting to do computer vision has actually been a really good draw of talent from the data science community. Data scientists who are looking for a job get really excited about being able to do computer vision research or learn about computer vision research because it is so exciting out there. So that's not the sort of thing that's super easy to measure, like that kind of boost in terms of dollars and cents. But yeah, we A/B test everything we put out. Thank you.
Yes, thank you so much. I took more notes.